Hey, welcome to Wednesday. This is a lesson that I've worked on a little bit, but this is actually a review, but I'm going to kind of treat it like it's the first time you've seen this with integers. But I wanted to start with a quick piece of humor. It's not loading on the slideshow very well, so this is just a screenshot, but it cracks me up because back in the 80s, of course, when the Teenage Mutant Ninja Turtles came out, everybody knew who they were, and I used to even know what the different headbands, their little masks. I knew which turtle was which, but I don't know that anymore. And then, of course, Mr. T. Every kid from the 80s could talk exactly like Mr. T, and we did it probably way too much. So here's that little picture for April Fools, and then we'll get rid of that and go to the slideshow. I've been having a little bit of an issue with my computer trying to run slowly. I had to fight down some other apps that were trying to run, so it's probably time for an update and a restart. We'll do our best to do that. Yesterday, I had a few people contact me about question number 1 on the page, and I thought I did a pretty good job of explaining it in the previous video, but I still had questions. So if you watch the video and you still have questions, then you might just look at the answer here, and we'll start there and work our way back. If you notice, the very first number on number 1 is 1/4, and the answer was 4. It was the reciprocal. We talked about reciprocals yesterday in the video. The reciprocal of 1/4 is 4, and that's what I was kind of trying to get you to see in this here. You notice that we'll start right at the equal sign here and work our way both ways out. The equal sign says the 8 are the same, but there's a change here. This is multiplication, this is division. Well, if you want your multiplication problem and your division problem to be the same, then you have to have reciprocals on either side. So 1/4 versus 4. I imagine if it had started with 4 times 8, then most of you probably would have flipped the second guy and known what to do. This time it's division on this side, so that was kind of weird. You really do, when you flip it, you get 4/1, but 4/1 isn't the way that we write the number 4. That's in its simplified and reduced form. This slide right here says nothing. That's the one with the humor on it and the quote of the day. I'll try to include that later. But there is a link, remember, in Google Classroom of this slideshow, and it should show up there. Just for the screencastify that I'm doing right now, it doesn't work. All right, so the paper that you have today should go pretty quick. It's about integers, and most of you have done some work with integers already this year. Remember that integers are the whole numbers and all of their opposites. So again, let's start in the middle at 0. If you go 1 space this way, it's 1. If you go 1 space on the left side of the number line, it's -1. So you have 1, 2, 3, 4 ongoing for the positive numbers, and then you have the negative numbers there, which are integers. Integers are whole numbers and their opposites, which means that 1/2 is not really an integer. It's not a whole number. So fractions and decimals don't have to be considered in this. Thank goodness, that would make things a little more difficult. However, there are such things as negative and positive negatives and positive fractions and decimals. So you'll want to be aware of that later. I've written this out here. The ... means etc. You know that. It means it goes on forever in that direction. Same here. -3, -2, -1, 0, 1, 2, 3 goes on forever. This is actually, these symbols are used in what is called set nomenclature. It's a specific set of numbers. In this case, it's the set of integers. It's impossible to write down every integer because it goes on for an infinite amount of numbers. So we do it in this manner right here. That's set nomenclature. All right, integers. You've seen integers before. You even work with them a little bit. This is where in class I say, I put the problem up on the board, 1 minus 2, and I say that in first grade or second grade you thought that was impossible, or at least you told the teacher that I can't do that. But you know now, because of your experience in life, that 1 minus 2 is -1. Well, you've seen that. That's what the check register over here is. This is a pretty complex one, but if you have to pay money, it goes out of your balance. If you get money in, it goes into your balance. So those act as negatives and positives. Those would be integers. Those are integers without the decimals, but if they have decimals, then they're not. It gets a little complicated there. All right, back to that screen. Sorry. You've also known about temperature. I always do this example in class. I say if it's 3 degrees outside and it drops 5 degrees, what would the temperature be? I don't have anyone hardly ever get that wrong. So you know that negatives are involved in temperature because you've listened to the weather. And the same thing with statistics. You've probably seen this curve in the news lately or on social media. This is what's called a standard normal distribution probability curve. It is used in a lot of statistics. We found out that in nature, a lot of times things happen in this manner. They're using it right now to say that we don't want it to happen in this manner. We want there to be fewer cases at the peak. And so we're trying to flatten the curve in cases for the coronavirus. And then the last thing listed there is physics or physical science. When you get into some high school physics, they use what's called vectors, and vectors have direction. Velocity has direction, negatives and positives. If you're going super fast but something's working in a negative direction against you, such as wind, it would slow you down. And so that's what they use in physics. All right, on to absolute value. Absolute value is something we've talked about as well, but it's very, very simple, which kind of confuses people. It is not negatives and positives. It's actually, no matter whether it's negative or positive, it turns positive. It is listed as a distance. So it's like, how much is this really affected? So in the example here, we've got 6, positive 6 is 6 away from 0, and so is negative 6. So absolute value is a lot like the distance there. You wouldn't say 6 miles or negative 6 miles unless you were talking about direction, and that's not absolute value. So absolute value is always positive. It's also defined as the magnitude of a number without regards to its sign, or a number's distance from 0. I always do the little swoopy marks. We do the, if you go from 0 to 3, that's like going 3 miles from Skyline to Pratt. If you go back, you're still going 3 miles, even though it's in a negative direction. Okay? Don't confuse absolute values with opposites. Yes, when you have a negative number, its absolute value turns positive, which makes that an opposite, but that's not always the case because positives also have opposites. Every opposite, such as 6, every integer, such as 6, has an opposite like -6. The only one that doesn't fit that is 0. 0 is its own opposite. And it's neither negative or positive. So that's the special case. So be careful when you're looking at absolute values. Don't think that those are the opposites. All right, that was a pretty short lesson. Just kind of a review. If you have any questions over that assignment, let me know. Email me, and I can put some more questions on here that we deal with every day.